So Module 3, we're going to be looking at VLANs. So there's several objectives here that you'll want to understand within this module. So notice a couple of these are explained. So explain the purpose of VLANs, how a switch forwards frames based on VLAN configuration in a multi-switch environment. And then the other three are configuration. So you'll need to know how to configure VLAN. So configuring a switch port to be assigned to a VLAN based on requirements, configuring a trunk port, and configuring DTP. So the first thing that's really important to understand is VLANs and what a VLAN is. So a VLAN is a virtual LAN. It's not a physical LAN, but the devices actually think that it's a physical LAN. And we use VLANs to separate the data that moves throughout a network. So we can group or organize, say, different departments. We can organize it however we want. Let's look at this example here where we have 3 floors on this building. Now, among all 3 of these floors, we have an IT area, we have an HR area, and we have a sales area. And they're spread across all 3. Well, with using a VLAN and organizing our information, we can have the IT group be spread across the 1st, 2nd, and 3rd floor, as well as the HR and the sales. Notice the names for these. So the IT group is on VLAN 2. HR is VLAN 3, sales is VLAN 4. Notice also that the IP addresses are located underneath. So these are the network addresses, because within VLANs we use different network addresses. Notice the significance here between VLAN 2 and notice the 3rd octet is 10.020. So VLAN 3 is 3, VLAN 4 is 4.0. So that would be one way when you're organizing the layout or the topology within your network, your addressing scheme, whatever you want to call it. Organize it so that it helps you identify a certain area. So for example, if I was organizing based on classrooms and I had classroom number was 101. So if I had classes in classroom number 101, I might have the 3rd octet be 101, and those are the devices that are within that particular classroom. So if somebody came to me and they said, well, this computer cannot access the internet, and I asked for the IP address, the 3rd octet is 101, then I know that that is in the classroom for 101. So it's just something to think about when you're designing each of your networks. So why do you want to have VLANs? Well, one thing that you can do is create smaller broadcast domains. So if you have VLANs, all of the data that moves through out that VLAN stays within that VLAN. It doesn't go to all the other devices. So you have smaller broadcast domains. It's a little bit more secure, okay, because that data stays within that VLAN. So the IT users only see what's in the IT area, same way with HR. It's more efficient. So you can, again, you can group people together. The VLANs, you can name them, make them a little bit easier to identify. Rather than VLAN 10, you know that oh, that's a faculty VLAN, or that's HR VLAN. You don't need to add new equipment to separate the information. You can actually just add in VLANs on one switch. You can add several VLANs. So by separating out or segmenting your network, you can have smaller broadcast domains. So that's less traffic, which should make for a little bit better performance. And then just for like project management, application management, having things separated, organized, certainly helps with that as well. Now there's various types of VLANs. Default VLAN is, like it says, it's default. So VLAN 1 is automatically created, so just out of the box. This is the default setting for a Cisco switch. All ports on the switch are assigned to VLAN 1. The native VLAN is VLAN 1 by default, as well as the management VLAN. And then another important thing about VLAN 1 is that it can never be renamed or deleted. So you can add other VLANs to the network, you can assign the ports away from VLAN 1, but you can never delete it. Now, the data VLAN is what we use to separate your user-generated traffic, so user VLANs. Your native VLANs are important because when we start looking at the tagging and looking at your various VLANs, you'll see that as VLAN traffic moves throughout a network, it has a specific tag added to the frame. That tag identifies the traffic to stay within that VLAN. So if you have VLAN 10 created, for example, you'll see a tag inserted at the beginning of the frame that identifies that frame belonging to VLAN 10. And that's the same with all the VLANs. But sometimes you have traffic that is generated by the devices that is not tagged. So that's where your native VLAN is. That's untagged traffic. So maybe older devices might use this. Your management VLAN is what you're going to use for your management traffic, like SSH, Telnet. So this is not user traffic. This is the management traffic that's kind of controlling all the user information on that VLAN. And then your voice VLAN. So if you're using voice over IP, you're going to want to set up a VLAN specifically for voice data. Okay, so it'll carry just your voice traffic. So in this case, they use VLAN 50 to designate your voice VLAN. So those concepts are important. You want to make sure you do your check your understandings. And then now we're going to look at your VLAN trunks. So I'm going to use this scenario here and kind of summarize some of the stuff about your VLANs. So when you're looking at this scenario, we can see we have PCs 1 through 6 all listed here. 1 and 4 are both on VLAN 10. We can see that right here. We have PC2 and PC5 located here. And then they're both on VLAN 20, and then PC3 and PC6 are both on VLAN 30. Notice the addressing scheme, like I mentioned earlier, that third octet is significant in that the third octet here is 10. So VLAN 20, the third octet is the 20, and 30 is the same way. So if you don't have VLANs in this scenario here, notice the layer 2 broadcast was sent and it goes out to all the devices. Notice they're all in the same addressing scheme. So data comes in one port, goes out to every other device. If you take this scenario and you trunk these two links here, so trunk this port and this one, list these as access ports, set up all the VLANs, then traffic that is starting or coming in on VLAN 10 stays on VLAN 10. Let's look at the scenario here. So notice that broadcast doesn't go out to all the devices or all the interfaces. It stays within that particular VLAN. So again, when you configure that, you would go in and tell the devices which ones would be access ports, which ports would be trunk ports. Going back to terminology from your CCNA1 course, we learned about intermediary devices and end devices. End devices are these devices like your PCs. So I'm going to go back up here to this other scenario because we had a few more devices. So all these would be end devices. Now, end devices are used to access the network. So those ports that are attached to them would be access ports. Whereas the ports attached to other switches or other intermediary devices, because you could also have a router here too, those would be called trunk ports. The trunk ports are used just to forward data. Okay, so they have different purposes or roles within a network, and we'll look a little bit more about that. I want to show you this VLAN identification with a tag. So again, we have our frame here. This is a typical frame where you have your destination and source MAC addresses, the type length fields, the data, and then your frame check sequence or your CRC value. So right in here, between these two is a tag that lists your VLAN ID. So that says, hey, all this traffic stays within that particular VLAN. So again, you have tagged frames and you have untagged frames. And they move within your network. And that data is tagged specifically for a particular VLAN. Same thing with your voice. So make sure you read through that. You can use your show interfaces. F018 switch port is what they've done here. And you can see that this port is set to access, so an access port on VLAN 20. It's also part of the VLAN, the voice VLAN, which is 50, so VLAN 150. You have a packet tracer and you have to check your understanding, so make sure you understand those concepts. Now, when you're looking at your different VLANs and your ranges on your VLANs, one of the commands you could use, the show command, would be show VLAN brief. This is kind of like your show IP interface brief, where it briefly shows you some information. So show VLAN brief would show us the VLANs that are listed and the ports assigned to them. Now, all of these ports and VLANs that are listed here, okay, all of these are done by default. So VLAN 1, again, all the ports are assigned to it by default. These other ports, 1002 through 1005, they're legacy based, but still they are set so that you cannot delete those. So make sure you memorize that. You see this in your normal range VLANs. Extended range VLANs are 1006 to 4094. Okay, 4096 is that upper boundary. So make sure you know that. Those are some facts you'll want to know. So when you go in and create additional VLANs, you'll create starting at VLAN 2 and going up through 1001. To create a VLAN, it's really simple. You go in and go to config T to get to your global mode. And then to create a VLAN, if you want to create VLAN 10, you just type VLAN 10. If you want to give it a name, assign it a name, you can do that next. And then that's it. So if you're looking at an example, so config T VLAN 20 name students. That's a student VLAN. That's what they're creating. So that not only do you have to remember VLAN 20, but you can look at the output on that and say, oh, that's the student VLAN. Port assignment. So to add ports to a specific VLAN, config T, go into the interface config mode, switch port mode access. So set it as an access port. Again, that would be a device attached to it. And then switch port access, and then assign it to a particular VLAN. So if you're looking at the output on that, config T, you're going into F06, which is right here on the switch. That's the one the PC is attached to. Switch port mode access, so set it as an access port on VLAN 20, because it needs to be on the same VLAN as the PC. So if you're doing both data and voice VLANs, you can do that. You can set a port to do both. Okay. So in this case, we have VLAN 20, they're creating it as student, they're creating VLAN 50 as voice. Then you can go into port 18, switch port mode access, switch port access VLAN 20, then do this configuration here for your voice. And they're adding that to VLAN 150. So what happens if you forgot to go in and type VLAN 20 or VLAN 150? When you issue this command here or here, it will give you this message here: access VLAN does not exist, creating the VLAN. So you can really skip a step. Okay. So I say you can skip a step, and I say that kind of quiet because Cisco doesn't really want you to do it that way. They would prefer that you go in and create the VLANs and then assign the ports, but that is not incorrect to do that. So if you were asked that on a Cisco exam, know that you can go in and do switch port access VLAN 20, and it will automatically create the VLAN if it does not exist. If you want to verify VLAN information, you have several options. Show VLAN summary, and you can see your different VLANs. Show interfaces, and then look at the switch port. You can see whether it's access mode, what the VLAN is. Here we have voice VLAN. You can change the membership. You aren't stuck. So once you assign port 18, if you don't want it in that VLAN, you can just type a no in front of the same command you used to assign it to that VLAN. So when you go in and look at it again, you'll see it's assigned back to VLAN 1. If you want to delete a VLAN, you can type no VLAN 20. That'll delete it. Now, when you go in and delete a VLAN, what you have to remember, this information right here under this caution, you'll want to reassign the ports that are on that VLAN to a different VLAN before you delete it. Because if you don't, you can go in and delete that VLAN. If those ports are not assigned to a different VLAN, they'll be confused and think they're still assigned. They'll just be unusable. So you want to go in and reassign those ports to a different VLAN and then delete your VLAN. Also, another important thing to remember, when you want to delete your configurations out of a Cisco switch, you're used to using the erase startup config command. The erase startup configuration command erases what's in your startup config, but it does not delete your VLAN database. So in order to delete the VLAN database, you'll want to use your command of delete flash VLAN.dat or delete VLAN.dat. So you'll do your erase start and then delete flash VLAN.dat or delete VLAN.dat. So it's important to do both of those, because if you don't delete the VLAN database file, it will still be there, and the next time you log in, you can't figure out why you can't ping from one device to the next. It will be because the VLAN database is still there, and that's preventing you from being able to have that communication between your different ports because they were assigned to various VLANs. The other thing you need to remember with this command that's really important is that you don't want to abbreviate this command by typing delete flash, because if you do, it will blow out the flash memory. Why is that important? Well, flash is where your operating system is, so that would be the equivalency of deleting Windows on a regular PC. It is really easy to if you type delete flash, you can erase the operating system off that device. It'll say, do you want to do this? Yes. And then that's it, it's gone. So how do you tell that on a real device? Well, you go in and look, and if you're physically looking at it and you're looking at those LEDs on the front, they'll all be amber and flashing repeatedly. If you connect a console cable to it and look at the device, it has no operating system. So you definitely don't want to do that. So use the whole command, delete flash VLAN.dat, or if you want to be safe, delete VLAN.dat. Just so you're not even tempted to type delete flash. So make sure you use your syntax checker and do your packet tracer here. And then looking at Section 4, we're looking at your VLAN trunks. I mentioned earlier that sometimes you have to trunk interfaces. Your trunked ports are going to be between two intermediary devices. Keep in mind that if you're trunking on one end, the other end will need to be trunked. Typically, when you have two interfaces that are connected by a link, they're going to have the same configuration on both ends of that link. If you want to configure a trunk on a particular port, it's config T, go into the interface mode, switch port mode trunk. So earlier we did switch port mode access, this is switch port mode trunk. Switch port trunk, and if you want it to be the native VLAN, you signify that here. And then switch port trunk allowed. So tell the device which VLANs are allowed to be on the trunk link. So if we want to look at this, in this particular scenario here, we have VLANs 10, 20, and 30, and it's moving through these devices. So interface, fast Ethernet, F01, switch port mode trunk, switch port trunk. Native VLAN is 99. We're going to allow traffic from VLANs 10, 20, and 30. If you don't allow that traffic to move through, the data won't be able to move through. That's really important to remember if you have another switch located in here. So I know I'm going to be jumping around just a little bit, but I want to go up and show you why this would be important. So looking at the scenario here, let's see. We'll look at this. So if we have VLAN 10, 20, 30, 10, 20, 30, so you have this scenario where this switch, you would say to allow VLAN traffic from 10, 20, and 30. Here, 10, 20, 30. Now, just because you don't have an access port off of this switch, you would still have to let it allow traffic from VLANs 10, 20, and 30, or it won't pass through this device. That is something that I see as probably one of the most common errors that's made. That's why I came back to this particular section, is to make sure you do the allowed VLANs. Because I'm telling you, because this is a mistake that I have made myself when I go back and I'm troubleshooting, is not allowing the traffic, because you just have a tendency to not think about it when you don't have user ports attached to the device. So again, you will want to allow it on all the devices. So now I'm going to go back to where we were. So here, switch port trunk allowed, and that's why 10, 20, 30, and 99. So they're allowing it from VLANs 10, 20, 30, and then the management VLAN. To verify it, you can use your show interfaces command. Show interfaces, F01, switch port, you see that trunk has been enabled. Okay. This .1Q is the protocol that's used to send that information. We'll talk a little bit more about that. Trunking native VLAN mode is 99. Now, if you decide you don't want F01 to be allowing that traffic, you can do no switch port trunk allowed VLAN or native VLAN and return it back to its access mode. So just back to the same default method that you had it before. So you're going to look at it, you see switch port mode access, and it's not trunked. So you get to practice configuring trunks in your packet tracer and lab. Make sure that you know that. That is a really important concept This is a real world concept. This is used a lot. Maybe in a mom and pop organization, would you see one VLAN only and that be your default VLAN? I've actually heard of that happening, but that is not the norm. The normal case would be to have various VLANs within a network that are created and devices attached to various VLANs for those benefits that we discussed earlier. Smaller broadcast domain, keep your traffic isolated. So having a good understanding of VLANs will be very beneficial in the workplace. So the last important concept here within Module 3 is DTP, or Dynamic Trunking Protocol. So your Dynamic Trunking Protocol is, I believe this is Cisco proprietary, and this is actually used to allow trunk links to communicate with each other into particular modes. So force them into a trunk mode, for example. So it actually works with the neighboring device to figure out what mode they want to be in. So we have switch port mode trunk command listed here. In this particular case, we have switch port mode trunk. It is not set to negotiate, but if you want to re-enable that, you can do switch port mode dynamic auto. Now there's various interface modes, and you'll want to know those. Now the access and trunk are not new to you because I discussed those earlier in the chapter. The access port is one you have a user or an end device connected to. Trunk port is what's between those intermediary devices. But you have two other modes that might be used for DTP, and that's dynamic auto and dynamic desirable. The dynamic desirable makes the interface actively attempt to convert the link that it's on to a trunk link. So it actively tries to do that. It has a conversation with the other end and says, let's try to trunk. Dynamic auto, it is able to convert to a trunk link, but it doesn't initiate that. So it is waiting on this desirable end to initiate. And once it does that, it will convert. So if you have two interfaces that are set to dynamic auto, you won't have a trunk link. This is what we're looking at here. So, like I said, dynamic auto, they're going to stay access ports. They're not going to try to initiate anything. If you have the other end a set of trunk link or a dynamic desirable where it's actively participating in the process, then it will trunk. Okay, but if the other end is set to access or dynamic auto, it won't initiate anything. Dynamic desirable, it desires to be a trunk link, so it will trunk unless the other end is set to access. Trunk links will trunk. You're telling it to trunk unless it's connected to access, and it'll be limited connectivity because you have two different settings. So you have one set to trunk link while the other one's set to access, and it doesn't work very well. If you have access ports, so they will stay access because you're telling them to. They will have very limited connectivity with a trunk port. So if you specify trunk or access, they will stay that. The only ones that'll change maybe are the ones that are listed as dynamic desirable or dynamic auto, because then they have the ability to adapt or change based on what they're connected to. Now to verify the different modes, you can go in and look at your show command. So show DTP interface FA0/1. You have a packet tracer to configure DTP and to check your understanding. and a packet tracer to kind of pull all this together. So in this particular one, you'll be configuring VLANs, assigning ports, static trunking, and configuring dynamic trunking. You have a lab also. Here it's configuring the 8021 trunk between the switches. So that is the protocol that's used for the trunking that I mentioned earlier. You want to make sure you know all the information that's listed in this what did I learn in the module. If so, you should be well prepared to take your module quiz and know that you have grasped all the concepts within these VLANs. And that would be important information to know, not only for your class, but for your CCNA. And it is the foundation of understanding the inter-VLAN routing, which will be our next concept.